Okay, welcome back students. So we were discussing the concept of random variable. The random variable concept has been discussed very thoroughly, and after that concept in chapter number 3, then in chapter number 3 of edition 2 there is another topic which is cumulative distribution function. If anyone is following the third edition of this book, so the topic of cumulative distribution function will be in chapter number 4. Okay, as I have opened the third edition of this book, therefore I am now going through the chapter number 4 of this book. So you guys can study it from anywhere you want. Okay, so what is basically the cumulative distribution function? As I have told you earlier that this is the cumulative probability function of any random variable. Okay, if any random variable x is a function from the sample space S to R, then the cumulative distribution function can be written like this. Okay, this is the cumulative distribution function for any probability of x less than or equal to the x. Okay, so this cumulative distribution function will be written like this: capital F, capital X into X, and it will be from minus infinity. X will be greater than minus infinity and less than the plus infinity. Okay, so this is the basic definition of cumulative distribution function. But what is this? Where is it used? Let's discuss it in another page of our book. So to discuss anything, let us first discuss the example which is related to the cumulative distribution function. So in this example, in figure 4.1a, okay, this is the figure 4.1a, and this figure shows the CDF or cumulative distribution function x, the number of heads in 3 tosses of fair coin. It is the same example we have seen earlier, in which the random variable was x, and what was x? X was basically the number of heads out of 3 tosses. It is the same random variable, and this is the CDF of that random variable. From example 3.1, we know that x takes on only the value 0, 1, 2 and 3. This was this thing, and what was that? It was basically s of x. Okay, the values of x were, those were 0, 1, 2 and 3. Okay, this was s of x. So now this from this s of x that are less than or equal to x, the resulting CDF is seen to be a non-decreasing staircase function, which is here. Okay, you can see that this plot, initially you should understand this plot, and this plot is also called PDF. It is also called the PDF of this function. This is probability distribution function, probability density function. This is cumulative distribution function, while this is probability density function. We will discuss it later on. Actually this is not PDF. PDF is considered in a continuous case, but this is PMF. There are basically two types. One is PDF and the other is a PMF, probability mass function. This is a PMF which is in this case. So what is the probability of getting no heads? This will be 1 by 8. What is the probability of getting 1 head? This 3 by 8. What is the probability of getting 2 heads? Is 3 by 8. And what is the probability of getting 3 heads? Is 1 by 8. Writing all these things, all the outcomes in this form is called probability mass function in discrete case, and probability density function in what? In continuous case. This is in continuous case. We will discuss it. Okay, we will discuss it later on. This is in continuous case, and this probability is in discrete case, discrete form. So you guys can see that this is the probability function, probability mass function. So we can get this CDF from this as well. Okay, so we were discussing the PMF and CDF. So what is basically this one? This is calculated from the PMF plot of this problem. From 0 to 1, this will remain 1 by 8. Okay, this will be 1 by 8 up to 1, and at 1 it will suddenly jump into this one. What is this value? This will be 1 by 8 plus 3 by 8, so this will become 4 by 8. This is basically in CDF you add all the previous probabilities. Here what will happen? This will be the probability that x is less than or equal to 1. Okay, so what will be the value of this? This will be equal to 4 by 8 as we have added now. This will be 4 by 8, or it will be equal to 1 by 2. Okay, what will be the value of the probability of x less than or equal to 0? What will be the value of this one? This will be equal to 1 by 8, because we don't have any other quantities below 0. This is starting from 0, so it will be 1 by 8, and the value at which this will be x is less than or equal to 1, this will be equal to 4 by 8, because this is now 1 by 8 plus 3 by 8. These two values will be added now. After it, to find the probability that x is less than or equal to 2, what will be the value of this one? It will be now here. Okay, it will be now here, and at this point at 2 it will suddenly jump at this level, and this level is basically now the addition of 4 by 8 and this 3 by 8. Okay, it will now move here, and this is now 4 by 8 plus 3 by 8. Okay, so it will now be, this is now 7 by 8. Are you getting my point? This will now be equal to 7 by 8. This is 7 by 8. Okay, so at the end, when it will come to 3 or more than 3, so the probability or the CDF here will become 7 by 8, which is this one. The value which was here at this level, this was 7 by 8 plus the value at 3. Okay, this is the value here, which will be equal to 3, and this will be equal to 1 by 8. So 7 by 8 and 1 by 8 is equal to 1. So at the end, so the value at x is greater than 3 will be equal to 1. Okay, it will stand here at 1. So you guys can see that from this PMF plot, which is the basic probability plot, we have got this thing. Okay, this is the CDF plot. You guys can also see it from this example here, that the probability of 0 heads is 1 by 8. The probability of 0 or 1 heads means the probability is such that the number of heads is less than or equal to 1. It means this thing, and this will be equal to 1 by 8 plus 3 by 8. This is 1 by 2, and it is plotted here. Okay, and let me change the color of my pen now. Okay, this is plotted here now. You guys can see here. Okay, similarly here, the probability of 0 or 1 head, and so on. So what will be the probability that the number of heads are less than or equal to 2? It will be equal to 7 by 8. And what is the cumulative probability that the cumulative distribution function, or the probability that x will be less than or equal to 3 will be equal to 1? Okay, because it encompasses all the probabilities. Either it will be 1 head, 0 head, 2 head, or 3 head, and all those limits come under the value of 3, because this is now all the values 0, 1, 2 are basically less than 3, and the 3 is basically this one, so it will be equal to 1. So this is basically the CDF. You guys have seen that it is very easy to find the CDF of any function if you have this PDF plot or PMF plot, so you can find it out very easily. So let's move on. We have seen this example. Okay, so this is again written here. What is this? This f of x is the, what is it? This f of x is basically the CDF of the any function x, okay. So this is the CDF of function, and it can also be written like this one. These are basically u of x are the step function which has value 1 greater than x for all x greater or equal to 0, and 0 for all the values less than 0. We will discuss it and you guys will understand this equation very soon. Up till now you should just concentrate over the random variables and how to find the CDF of any function. Okay. So it was all about the CDF. You guys should also answer and solve all the questions in your example. So please do all the exercising and all the examples as well. Okay. This is another example. So I am not doing it. I am leaving it to you guys. Please look at this example, and after looking at this one, it will be very easy for you guys to solve the exercise question. Okay. So there are some values, some properties or axioms related to the CDF. Every CDF value will always be greater than or equal to 0 and will always be less than or equal to 1. Its value cannot be out of this 0 and 1. Okay. Similarly, if you find the limit x approaches to infinity up to infinite value, it will be equal to 1, because I have told you that after some staircases it will stabilizes at the form of this one, and the value at this stable curve will be equal to 1. Okay, you guys can see that at this left side the value here will be equal to 0. Okay. Similarly here, these things are not that much important, but these three properties are very much important. So just have a look over these three problems, and all the proofs are also written here below this article. Okay, let's move on. Okay, there is another property which is very important, and this is property number 6. If you want to find out the probability of any event x which is in between A and B, so you can find the probability by if you have a value of or if you have a CDF value at point B and CDF value at point B, so you can find this value by subtracting the higher value from the lower one. Okay, it is very easy. Let's say you have a value in previous example you had value 7/8, and you had this was the value that you should get all the heads greater or equal or less than 2. Number of heads will be less than or equal to 2, and you want to find out the other values, so you can subtract other values from this one, and other range values can be found out through this example if you have other CDF written here. Okay. Similarly, if you want to find out any value at certain instant, how can you find it out? You can find out the value at the instant minus the value very near to that instant. What is this minus? This minus means if you have to find out the value here, which let's say this is B, so what will be the value? You have to subtract it from this very near value, and this very near value is this B minus. Okay. This property is again very important. Property number 8 or axiom number 8. If you want to find out the probability which is next to certain level, okay, if you have all the values here and you want to find out the values here, you know that the total values here are 1 and the values here, the CDF here is fx. How can you find out this value? Okay, you know the total value which is 1, you will just subtract this f of x from this one and you will get the value of this x, such that it is, this portion is greater than the x. Okay, so this is the value here. Okay, so this is all related to the CDF. We will discuss the PDF and PMF in our other video. I hope you have gained some insight into the concepts of CDF, random variables, and other important topics in today's video. I will try to cover the PDF and PMF in our next video. So after this video we will discuss PDF and PMF. Thank you so much, and I will see you in the other video.